Welcome back, everybody. Let's do another example. So this example reads, the authors of the paper, Facebook and Academic Performance, investigated the relationship between the college grade point average, that's GPA, and Facebook use. One question that the researchers were hoping to answer is whether the mean college GPA for students who use Facebook is less than the mean college GPA for students who do not. Two samples, 141 students who were Facebook users and 68 students who were not Facebook users, were independently selected from students at a large public Midwestern university. Although the samples were not selected at random, they were selected to be representative of the two populations at this university. Data from the samples were used to calculate the sample means and the standard deviations, which we see below. Perform the desired hypothesis test at the 0.01 level of significance. All right, so we're going straight in. Read this again. And again, the main takeaway from this is that, notice, we're computing average GPA. So the word average already indicates that we're dealing with a quantitative variable. And therefore, we're going to be talking about mean. So it's mean GPA for students who use Facebook and those who do not. So Facebook users versus non-users. So Facebook users, we're going to call that group 1. Non-users, we're going to call that group 2. So let's go ahead and perform the hypothesis test. And I always like to start out with the parameter. So mu1 would be the mean GPA of Facebook users. And then mu2 would be the mean GPA of non-Facebook users. All right, now let's get our hypothesis going. Remember that the hypothesis here would be that mu1 equals mu2. And the alternative, let's see, what is it that they were trying to determine? One question was whether the mean GPA for students is less than the GPA who do not. So that means what they're saying, this is less than the students who do not. So mu1 is less than mu2. Remember that we can write these as mu1 minus mu2 is 0 versus mu1 minus mu2 is less than 0. I see that we don't have a lot of space, so I'm trying to use this, space wisely here. So we've got the proportion, the hypothesis. Now, are the requirements met? So for group 1, remember, they said it was not random, but it was representative, which is really the whole point of selecting a random sample. So we're going to go ahead and say that, sure, SRS independence. And then finally, the normality condition. Well, we don't know, or not the normality, sorry, the shape. We don't know if that's satisfied, but luckily we don't need to because the sample sizes take care of that. So N1 is 141 and N2 is 68. So in both of these cases, we have a big enough sample for group 1 and for group 2. Okay, so, and then group 1, we say N1 is 141. That's definitely greater than 30. So we got the large sample in our favor. And then 2 is 68, greater than 30. So we're good to go there also. All right, let's go ahead and sketch a t distribution. Now, this t distribution, I'm going to go ahead and sketch with the degrees of freedom of the smaller of these. So the smaller of these is 68. So degrees of freedom is 67. And because I see a less than here, this will correspond to a left-tailed test. So this is alpha, which is 0.01, as indicated by the level of significance. So I can go ahead and find this critical value. So we've already seen this a few times, so let's go ahead and use StatCrunch for this. So pause the video and go find the critical value, and then I will write it in. All right, so I hope that you tried it. I have on my paper that this is negative 1.6679. I hope that that matches with your answer. If it does not, please reach out. Ooh, you know what? I don't think it will match because on my paper, it doesn't have this. So let's just find it. Stats calc, T. Oh, degrees of freedom was 67. And my tail should be 0. I think it was 0.01. 0.01, yes. So I can see that, yeah, this was not correct. This was for 0.05. All right, so we get negative 2.383. All right, so now with the correct critical value, we can go ahead and find our test statistics. So our test statistics, that'll be the t-stat and the p-value. And so I will simply go ahead and use StatCrunch. So I'm going to go to stats, t-stats, because I have a mean, go to 2 samples. And in this case, we don't have data, but just a summary. So we are going to have to report the summary statistics for sample 1 and the summary statistics for sample 2. So please remember to use the correct sample. Sample 1 is Facebook users. So that's 141, 3.06, and 0.95 as the sample summary. And then group 2 will be the 68, 3.82, and 0.41 in their relevant places. So the sample mean, it's 3.06 for group 1. Standard deviation, 0.95. Sample size, 141. The second one, sample mean, is 3.82. Sample standard deviation is 0.41. And my sample size was 68. So that's all the information that we need. Make sure that you fill in the correct hypothesis test. Always 0 on the right-hand side. And then we had a left tail test. So that should be a less than. And we can read our test statistics here. So let's copy that down. All right. So again, if we throw this onto our sketch, we can see very clearly that our sample is way off into the left tail. This is this center here is 0. This mark at negative 2.38. So we got to go about 4 times as far as that. So in reality, we would like way over here if you extended the number line. So obviously, this is very significant. The p-value also is very, very small. So this would be a significant sample, even at the 0.001 level of significance. So this is extremely convincing evidence that our alternative is correct. So we're going to go ahead and reject the null. And you can go ahead and interpret this. So remember, our interpretation will be that we have sufficient evidence at the 0.1, actually 0.01, so 1% level of significance, to support the claim that the mean GPA, so mu1, that was the mean GPA of Facebook users, is less than the mean GPA of non-Facebook users. And that is our conclusion. All right, so remember that hypothesis test is not good because it doesn't really tell you by how much on average that is. And so that's why we have our second part here, which is find the confidence interval for the differences between the means. So I'm simply going to go back to StatCrunch and adjust what I want to perform. It's not a hypothesis test. It's going to be a confidence interval. Now, careful here with your level, because on my paper, so this paper I keep updating it. So here my alpha value, my level of significance for part A was 0.01. So that means my confidence level is 1 minus that. So that's 0.99. So I'm going to go ahead and update this to 0.99. And here we have our confidence level. Let me write that down. So we're pretty confident that mu1 minus mu2 is between negative 1.0049, so I'll just say 5, to negative 0.515. Now let's go ahead and interpret this in context. So notice the fact that this is negative and negative, that means that we're good, that the 0 is not included, so the mean should, the difference between these should not be 0, which we already know because we rejected. And because these are both negative, it means you got to go to the parameter with the negative in front of it and say that mu2 is therefore larger on average than mu1 by anywhere from 0.05 to 1.0. And that is a ridiculous result here. So remember that mu2 in context was the mean GPA of non-Facebook users. So this is an old study. That's why Facebook is the main one. I guess now it would be like TikTok or Instagram. So the mean GPA of non-Facebook users is higher, not larger, sorry, higher than mu1, which is the mean GPA of Facebook users by, notice it's 0.5 to 1. So it goes from about 1/2 a GPA point to a whopping full GPA point. So that's a humongous difference potentially in the population according to this data. And we kind of see that here. The sample mean for Facebook was 3.06 for users. Non-users was 3.8. So it's a very significant jump just from the sample. But now we can say with confidence that the true difference is at least 0.5 percentage point GPA to as much as 1 whole GPA point. So this, again, is why you want to use the confidence interval after you perform a hypothesis test. It's a lot more meaningful than the hypothesis test. All right, that was our last example. So if you have any questions, please make sure that you reach out.